Example 3, write an expression. So we're going to write an expression, and I look at it, and it's all words. This is just like the last example, except now there's more context to what's going on. There's a story involved with it. And if you ever have struggled with word problems, I understand they can be difficult for people, but here's my biggest hint, and you should write this one somewhere that you can always see it whenever you get to a word problem and you feel like you're stuck. The word problem is always based on what you learned that section. Okay? We just learned how to take a verbal expression, something that we could say or write, and turn it into an algebraic expression. This is something that we could say or write, and we're going to turn it into an algebraic expression. It's the same exact thing, it's just it's got more to it. More to it in terms of like there's a person involved, and there's keys, and there's logos, and all this other kind of stuff that can throw you off. But really, the heart of this problem is they're describing some sort of expression, and you're going to write it down. So when I read through the problem, I usually like to read through it one time and just give it a read through. That way when I read it the second time and start looking for stuff, I might notice if I read something wrong. Mr. Martinez orders 250 keychains printed with his athletic team's logo and 500 pencils printed with their web address. Write an algebraic expression that represents the cost of their order. Okay, so does it really matter that it's Mr. Martinez? No, it could have been anyone. So I'm almost going to ignore that part. But I do, when I'm reading this, Mr. Martinez orders 250 keychains. That's him doing something there. And 500 pencils. What's printed on them? It doesn't really matter that much. I mean, could those two things have been reversed? Yeah, the keychains could have had the web address, and the pencils could have had the team's logo on it. So those parts really don't matter that much. We're going to write an algebraic expression that represents the cost of the order. Well, now you have to think about the word cost. What does cost mean? Well, think about the last time you bought something. Let's say you went to, some market the other day and you bought a Gatorade and some Takis. Well, each one of those things has a price, right? And then they added those prices together. Now, if you'd bought 2 Gatorades because you were going out to play basketball and you knew you were going to be super thirsty, you would just take the price of that Gatorade and multiply it by 2 first, right? The quantity multiplied by the price. And that is the key to knowing what the cost of an order is. The quantity times the price. Now, one thing here is I didn't see any prices at all in any of this stuff. I don't know how much money he's actually going to be spending. But that's where variables are in. That's a number I don't know, but I know it's supposed to be there. So I'm just going to call them some sort of variable. Now I've got keychains and pencils. I'm going to make up costs for each one of them because they probably don't cost the same amount. A keychain is probably more expensive than a pencil. So here's what I'm going to do. I see I've got my quantities here, 250 and 500. 250 keychains. How about K for keychains? And 500 pencils. P for pencils. Now, with both of these expressions right here, they're independently the cost of each thing. 250K is the cost of the keychains. 500 pencils is the cost of the pencils. 500P is the cost of the pencils. So what I'm going to do is to find the cost of the order. The whole thing ordered together is ordering them at the same time. I just add them up. Just like the Gatorade and the Takis getting added together at the cash register. And there's my expression for the story that we just told about Mr. Martinez buying some stuff for his team. All right, that's the end of that lesson, and I will see you in the next one.